Welcome. Now we are going for problems where symmetry is not there or where you require sigma m and sigma v both. Okay. Question 28. I will dictate the question in words. Up to some time I will dictate. See, first you should do one thing. How the question is dictated or based on that one, you should prepare a sketch. A beam is of length 17 meter. So that is, they are telling total length 17 meter. No paste right here. 1 nimisha. 17 meter. 457.85. This answer, final answer. 0.15. Okay. A beam is of length 17 meter. So what you do? First you draw a beam of length 17 meter. Okay. End to end 17 meter. It is simply supported at 3 meter from left end, see, one support, and at 4 meter from right end. Okay, now the question can be given in different ways. See, a beam is of length 17 meter. It is simply supported at 3 meter from left end and at 13 meter from left end. 3, so another 10. Or it is simply supported at 4 meter from right end and at 14 meter from right end. Or a beam is simply supported between two supports 10 meter apart and it has left overhang of 3 meter, right overhang of 4 meter. Or lastly, easiest one, which what everybody wants, for the beam shown in figure. Okay, this much over now. It is loaded by UDL of 25 kilonewton per meter over the entire length, full length. Partial UDL will give it later. Okay, now there are 1, 2, 3, 4, 5. See, 5 concentrated loads. See, order is maintained of magnitude 100 kilonewton, 200 kilonewton, 150 kilonewton, 140 kilonewton and 200 kilonewton. At left extreme end, so 140 at left extreme end, at 5 meter from left end. This is 3, so it will go somewhere here, at 9.2 meter from left end, at 2.4 meter from right end here, and lastly at right end respectively. Instead of all these statements, usually what they'll do, give the sketch. Okay, find vertical reaction. Very important question. One, I'll explain many important principles here. Next time I won't tell all these things, but somebody in the classroom they will tell, sir will tell once again. Okay, as usual, don't see this one. VA upward, VB upward, B reactions usual. Prepare a neat sketch. Now, instead of marking this way, mark the overhang, span and overhang. This 2.4, see these two loads, you mark from here, instead of marking here. See, 5 and 3 means 2 meter and 9.2 minus 3 is 9.2 minus 3 becomes 6.2. 6.2 from here, or already 2 here, 4.2. Or you can do one thing, 9.2 minus 5 is 4.2. This way mark it. Okay, now sigma m about A0. See, remember, when you take moment about sigma m 0, you can take either moment about A or moment about B. Both support has 1 reaction each. This is told many times. If you take moment about A, VA into 0, I won't write it. You will get the value of VB. Or if you take moment about B, VB into 0, you will get VA. It is completely your choice. Sometimes what happens is, usually you take moment about the left support. Don't take moment about C. Then both unknown will come. Moment should be taken always better, not a rule, about a point where unknown is there. So usually we take left point, habit. But some rare cases, instead of moment about A, if you take moment about B, it is advantageous. I will tell you what the advantage is. For example, suppose the beam this way. Suppose some uniformly varying load given this way. Up to some or anywhere up to here. See, up to here. Okay. If you take moment about A, see here. This load will create clockwise moment. This will create anti-clockwise. So if you are separating it here, one trapezium will come. But if you take moment about B, full triangle will come. So sometimes you have to observe it, which point is better. I will tell all these one by one afterwards. So now today's class, what I will do is, it's an important question, only one question in the class today. I will first solve sigma m about A0 right here. You take moment about any point. Statement I am not writing now, algebraic sum of moment. When you do sigma m0, complete beam you have to consider. Look this side and this side also. That is for BM later, only one side you have to consider. Don't worry about it now. Now, you can take moment about any point. I will solve first moment about A. We will get VB. Sigma V0, we will get VA. Then, to understand better this question, I will take moment about B first. This is cancelled. Then you will get VA first. Sigma V0, you get VB. I will solve both of them systematically today. Okay, start. Moment about A, thousands of time told for you. Finger should be at A. Every load into distance from A. Okay, start. First unknown. VB into 10 anti-clockwise. This is usual. Minus VB into 10. See, I am still putting that dot. 10 over. Now see, I will first do one thing. I will cover all the loads which are to the right of A. I won't see this side. See now. All these loads which are to right of A will produce clockwise moment. So one by one. First point load. 200 into 2. Clockwise. All are clockwise. Plus 200 into 2. See. Load into distance. 150 into 6.2. 140 into plus 140 into 10 plus, see, this is 4, this is 2.4, 10 plus 4 is 14. From 14, subtract 2.4. Or you can do one thing, you write the distance, how much it is. If it is 2.4, it is 1.6 meter if you want. So 10 plus 1.6 is 11.6. Okay, then plus 120 into 14. All these are point load into distance. Now UDL. When it is UDL, this side UDL will produce clockwise moment. So plus, see, I'll put here now, plus 25 kilonewton per meter for the entire length here. 10 plus 4, 25 into total length is 14. See, this is the load into center because it is starting from here. 14 by 2 clockwise over. Now, if you got difficulty, see a note here. See, note only for UDL. For UDL, see, A is here. This is D. B will not come. B is somewhere here. We are not interested in B. This length is 14 meter. 25 kN per meter. For 14 is the total load, 25 into 14 into 14 by 2, clockwise. Then come this side, minus 100 into 3, minus 100 kilonewton into 3. Again minus UDL, 25 kN per meter for 3 meter, see here, 3 meter, into 3 by 2, anti-clockwise. So minus 25 into 3 is the total load into 3 by 2. All over, yes, equal to 0. Everything is over. 200, 150, 140, 120, UDL. Yes, everything is over. Therefore, you get the value of VB. Solve and get the value of VB in kilonewton. I do not want to waste time. I already got plus 667.15 kilonewton. In case wrong means check once again. Okay, then next sigma V0 upward positive. Make a note. Now only load, no into, no distance. Plus VA plus VB, upward positive. Minus 100. Now not clockwise, anti-clockwise. Now upward, downward. Minus 200. Minus 150. Minus 140. Minus 120. Minus 25 kilonewton per meter for entire length. So this time, see, it's already I told you. When you want sigma, when you are applying moment about this point, this side UDL will create clockwise, this UDL will create anti-clockwise. So you separate it here, but this time you want only load. So minus 25 into directly single step. Waste of time, 25 into total load, into 17 equal to 0. Then substitute VB equal to plus 667.15 kilonewton. You substitute that value, simplify, you get the value of VA. I do not want to waste time unnecessarily on these things now. VA will come 467.85 positive, 0.85 kilonewton over. Now, write immediately. Therefore, not there. Once again, put the original beam here. If you are serious, then write. Therefore, vertical reactions at the supports will be as shown below. Mark a reaction VB here of 667.15 kilonewton. This is the final. See, I already told you, you got both positive, means assume direction correct. And here, it is giving trouble here, is 5 meter, etc. You write afterwards. VA equal to 467.85 kilonewton. Okay, then if you want, write that this cut distance and other distance. You write here, no space. You write the distance if you want, somewhere here. If you want, write here, 5 meter and I don't know how much it is. Enter the values. If you want. Okay. This is solution. Now, one very important note I will give at the end of the class. Not now, end of the class. See, 1 minute. When you take moment about A, this UDL will produce clockwise moment. This UDL will produce anti-clockwise moment. So, this is, see, you can wait, this is for this side UDL, this is for this side UDL. Okay, now everything is over. Now make a note here. Write a note. I'm rubbing everything. We considered moment about A and then sigma V0. If you, sometimes it is better, there will be advantage if you take moment about B, or some problem. You, for some reason, you want only VA, objective question. They want only VA. In that case, why you want to waste time? Take moment about A, get VB, then make sigma V0. Directly in the beginning only, take moment about A. Sorry, moment about B. So right here. Now we will solve again by first considering sigma m about B equal to 0. Okay, right. Therefore, solution sigma m about B equal to 0, take clockwise positive. Now be careful. This sketch will go now. See, now start. Moment about B here. First this side. Plus now clockwise, plus VA into 10. 10, is black color, it is not unknown, okay. VA into 10, here, moment. Plus here, minus 100 into 10 plus 3, 13. All this will see, this VA in 10 is clockwise. All the loads this side will produce anti-clockwise moment. Minus 100 into 13. Minus 200 into 8. Why? 10 minus 2. Minus 200 into 8. Minus 150 into, this is 10, this is 2, this is 4.2, this is total 6.2. If it is 6.2, this will be 10 minus 6.2 is 3.8. 150 into 3.8. See, correct. 3.8 anti-clockwise. Then, see, moment about B. And then UDL. Now see, moment about B you are taking. This side UDL, I will make a note here. Make a note. Our moment point is B now. Somewhere make a note. Moment point is B. So this side UDL is for a length of B up to C. A will come somewhere here. 10 plus 3, 13. First of all, I already told this one. See, now total load will be equal to, how much it is? 25 into 13 kilonewton. From B, it will be acting at 13 by 2. Whereas the UDL, which is right side, will be B to C, B to D, for a length of only 4 meter. And that UDL will be acting here 25 into 4 kilonewton total load, acting at half of 4 by 2. So therefore, when you take moment about B, now minus 25 into 13 minus 25 into 13 is the total load into 13 by 2. See, this is for UDL, left UDL. Then when you go that side, all this load will produce clockwise moment, plus 120 into 4 plus another 140 into 1.6. If it is not there, 4 minus 2.4. Then lastly, plus 25 kilonewton per meter for 4 meter. Already explained just now here. Into this is a total load into 4 by 2 equal to 0. All over 200, 150, 120, 140 all over equal to 0. Therefore, you get the value of VA first. VA will come in kilonewton. It will come plus 467.85 kilonewton. Some will tell, sir, cheating. Not cheating. I know the answer will come. I already checked it. Checked not by this way. When I took moment, I was careful. Okay. Then, sigma V0, take upward positive. I will tell some more interesting concept today. Upward positive. Plus VA plus VB. Now, only load minus 100. I waste time now. Minus 100. Minus 200, minus 150, minus 140, minus 120, minus UDL from C to D, only load you want, no distance required, 25 into total length is 17, minus 25 into 17 equal to 0. Substitute your VA equal to plus 467.85 kilonewton, you will get VB equal to 667.15 kilonewton. Oh, therefore, right here, therefore, for the given beam, support reactions are as shown below. Write the sketch once again. Perfectly tallying. See now. Now, over. Now there is one very important concept for those who can understand, actually not difficult. See, I will tell once again now, all over now. See. Okay, this is over. Now make a note. It will help you. Note. What I dictate, you write. What I dictate, you write. First consider sigma m about A0. First solution. A0 clockwise positive. Okay, take point about A. Minus VB into 10. I am going back to first solution. Then point load all you write. Okay, see. Minus VB into 10. 200, 150, 140, 120, 100. All you write. Okay, that all you write. When you come to UDL, what we have done is right side UDL from A up to D will produce clockwise moment, whereas UDL from A to C will produce anti-clockwise moment. So we separated best for you. Or instead of separation, you can do directly also. See, what you have to do is see here. Full UDL, see now. What length? This total length is 17 meter. The total load will be somewhere here. This is only for those who can understand 25 into 17 kilonewton. It is acting, see, this point is C, this point is B, not B, sorry, this is D, D. Our moment point is A. From C, it will be acting at 17 by 2. Therefore, when you consider moment of UDL, you write there, moment of UDL. Last time we took 25 into 14 into 14 by 2 clockwise minus 25 into 3 by 2 anti-clockwise. Instead of that way, you can write 25 into 17 into, see, from C to resultant load is 17 by 2. But this distance is 3 meter. So into 17 by 2 minus 3. See here, 17. From A moment about A, it is acting at 17 by 2 here. See, from here to here is 17 by 2 minus 3. And since the load is acting on the right side, resultant, it comes this side, it will produce clockwise moment plus. But by chance, if this overhang is too much more, if it acts here anti-clockwise, I will explain later. Okay, plus sign. Those who can understand, go for this one. Over. Now do one thing. See, minus VB into 10, etc., etc. Calculate. UDL, instead of taking 2 times, take only once, but be careful. 100% answer will come 667.15 kilonewton. Or, make a note here. Or, suppose you go for sigma m about B, 0. Then, see here, B0 plus VA into 10, all point load, this one, already explained. So it is plus VA into 10, point loads all you write. When the time comes for UDL, what to do? See here. This is C. This is D. Actually, what you have done earlier is, you have done UDL from C to B is for 13 meter length. 25 into 13 by 2 anti-clockwise and 25 into 4 by 2 clockwise. Or you can take C to D directly single step. Total length of load is 17 meter. So this resultant will come somewhere here. How much it is? 25 into 17 is the total load in kilonewton, and from D it will act at 17 by 2. 17 by 2 meter. But our moment point is B here. This is how much? This is 4 meter. Therefore, when the time for UDL comes, what you do is, see here, total load 25 into 17 is the total load into moment about B you want. This is 17 by 2. This is 4. 17 by 2 minus 4 into 17 by 2 minus 4. Then usual equal to 0 or to make it, you will get the value of VA guaranteed 467.85 kilonewton. So what you have to do is, first you have to locate where is line of action of the total load. Then see which point you take moment. First you locate the line of action from the end of the UDL. Make a note here. First you locate line of action of the load from the end of UDL. Then if your point is outside, there is no problem. This trouble will not come. If the moment point is inside, see how much inside you have to come. Subtract that distance. Then, very important, if the total load comes on this side of the moment point, clockwise moment. If the total load comes this side of the moment point, it is anti-clockwise. See, I wrote here, it is minus here. Minus. Why? Anti-clockwise. Be careful. This advantage. I will tell you why this is useful now. 1 minute. I will tell you why it is very useful. A question will come later. See, I tell a question here. This way type of question. See now. When you want moment about A, now if I look this side separately, a trapezium will come. Again you have to divide into rectangle, triangle, etc. This side triangle will come. Or when you want moment about, if you want to take moment about B, this side trapezium, this side triangle will come. But what you can do is, you can find out the line of action of the total entire load. I will explain later. Full load. See, this distance. From here, it will be 2/3 of this full length. Then you know this distance, moment point. Then the total load into what? This 2/3 of that length minus this one. Or if you are moment about this point, this will be 1/3 of this length. So when you are moment here, it is this total load into this distance. This I will explain later. At that time, once I will consider left side, right side separately and show you the difficulty. Oh, it become lengthy. Then I will tell you easy approach. Later, when the time comes. So right now, correctly solve this question and get the answer. Practice repeatedly. Just one exercise I will give for you now. Unsymmetrical. Just one exercise for you. Simple question. 20. No numbering. One question for you to solve. Briefly, not much loading, but correctly solve. I won't explain anything now. Direct answer. Even in the notes also, this question I won't explain. Because why? This much explain. Still, if somebody wants explanation, he is not fit for studying. Okay, see. Simple question. Full UDL, no change. Just 2-point load. 3 meter well. 2 meter, 8 meter, not wet actually. This is 2.5 meter. This is 7.5 meter. UDL of 30 kilonewton per meter. This is 90 kilonewton. Here 120 kilonewton. A and B, solve the question, get VA and get VB. Simple question, no other loading. These are the questions you require for SFD BMD. I will give answer for you. VB will come 328 kilonewton positive, VA will come 242 kilonewton. Anyway, I'll check the answer once again. Before I give the question for you, I'll check the answer once again. 2.5 hope visible. 2.5 meter, 7.5 meter because wet surface. $242. Yes, perfectly correct. 100% correct answer. Solve this question and get ready for more questions next time. Okay, thank you.